Number 33. Jose is purchasing a new car for $27,500. If the value of the car decreases at a rate of 11% per year, approximately how many years will it take for the value of the car to decrease, or rather reach $12,000? So this problem is one where we have a certain money value depreciating over time. And so I'm going to go to the formula chart to exponential functions, and we look in here, and it appears to be 5 different options. But truthfully, we can solve all of our problems either using this compound interest formula or the continuous compound. Now, if the problem had said continuously decreasing or exponentially, that's what that E stands for, we would use these formulas. So here's exponential there as well. These formulas are basically the same, and these are basically the same. The only thing different is this n is when it's not equal to 1. If n were 1, it would disappear because r divided by 1 would be r, and 1 times t would be t. So this n right here is talking about the number of times per year. And the key word there is this per. So when I come back to the problem, I notice that this says per year. And technically, it's meaning it decreases at 11% per 1 year. So I'm going to say n equals 1. So I'm going to use the formula. A equals p, 1 plus r over n to the nt. And since n is 1, 1 times t, that'll go away, and r divided by 1 will go away, so it'll just be like that. So my 12,000 is my final amount. That's the 12,000 over here. 12,000 equals p, which is 27,500, times 1 plus, we have a rate, I want to say decreases at a rate of 11% per year. That means it's a minus 11%, which is going to be equal to a negative 0.11. So when you erase the plus and actually put a minus 0.11 to the power of t. So to solve this, doing a little algebra here, I'm going to divide by 27,500. And we could solve this, but for the sake of time, I'm just going to do some algebra here. And I see these zeros can erase. 5 will go into both those numbers, so let me go see what this is. So our calculator, we would have 1, 2, I'll type in all 3 if you want to divide it, 12,000 by 27,500. Press enter, that's 24 over 55. So 24 over 55 equals, this right there simplifies. 1 minus 0.11 is 0.89 to the power of t. Now, since this is exponential and I'm trying to solve for power, I'm going to switch it to a logarithm. I'll say log. So this is my base. It's my power. This is my number. Log of the base, 0.89, to my number, which is 24 divided by 55, will equal t. So come over here, log. My base is 0.89 to the power of 24, or excuse me, to the number 24 over 55. So it's 7.12 years when we round it. 7.12 years. And this would be our answer. Now, if you wanted to, from after we've gotten the original formula, you could have solved this originally. I'll show you that. If I go menu 3.1, that pulls up solve, and I'm going to type in 12,000 equals 27,500, 1 minus, and you can even type in 11 as a percent. The button next to G right there has the percent, 11% to the power of t. And we solve for t and press enter. You notice it's exactly the same answer. So we did do this correctly.